Well, in this video, I want to show you how, because part of our steps of doing logistic regression in Excel is understanding optimization. So I want to show you an application of optimization applied to simple linear regression to kind of get you thinking about it. So this is a problem that we've already done. This is the trying to predict the number of wins a team has as a function of how many yards their defense gave up. And I'm going to bring the wins over to the other side. And then from this, I can build an XY chart. Whoops, that's not the one I want. Build an XY chart without the lines. Right click on one of the data points. And there you go. That is a regression equation where a scatter plot in getting the equation gave us the slope and intercept. Well, let me show you a different way to get the slope and intercept. And I'm going to use optimization to do it. Now, optimization is all about letting Excel find a best answer for you. So let's say that I don't know what the slope is. I'm just going to right now say, well, I don't know what it is, but it's 0. And I don't know what the intercept is. It's also 0. I don't even know what they are. But if that's my slope and intercept, and these are the wins that my prediction, what really happened, this is what my predicted wins would be based on using this slope and intercept. I would take my slope multiplied by my x value plus my intercept. And I'm going to copy this formula down, so I'm going to put some $signs around my slope and intercept, copy it down. So if the slope and the intercept are 0, and again I just guessed on those, then my predicted wins is 0. Well, what really happened was 10. Well, obviously there's an error. So let's calculate the error. The error is equal to this minus this. And if I copy that down, sometimes, at least in this case, they would all be positive. But I'm going to go ahead and square this so that if it's positive or negative, I get the magnitude of the error. So this is actually going to be the error squared. And I copy that down. So every one of these is an error because this is what happened. This is what my model based on a slope and intercept of 0 are. So I could actually say this is my total error the sum of all these errors. So what I want to do from an optimization standpoint is to determine what these values should be such that this error is at its smallest. Does that make sense? I want to make these numbers something, and again, I don't know what the scatter plot is. I can't use this, so I can't cheat. I want to determine what these are such that this value is my smallest. Well, how I want to do that is use something called Solver. So Solver, if you have Excel, a Windows-based, or you go under Options, Add-ins, Go, and you want to have the Solver add-in. And when you have the Solver add-in under the Data Worksheet or the Data tab, you have Solver. So I'm going to click on it, and a form pops up. So for this particular problem, because Solver can be used in a lot of different situations, but for this particular problem, I want to set, my objective is to take this value and make it as small as possible. And the cells that I'm going to let Excel have control over are my slope and intercept. And the last thing is I don't care if my slope and intercept are negative. If they're negative, they're negative. So I don't want to force them to be non-negative. And that's it. It's that simple. It's an unconstrained optimization problem. I don't have any constraints. There's my objective, trying to make that as small as possible by changing these two cells. So now I hit solve, and it says it found a solution. Look at there. There's your slope. There's the intercept, which is really, really close. So close I'm not too worried about as the slope and intercept of what we got with the regression equation. So see, even if I didn't know how to do regression, but I knew optimization, I could still determine my slope and intercept so that it would try to minimize the error between wins and predictions. Okay, so that is introducing you to optimization, and we need that. We need that when we do logistic regression. We don't need it for regression because Excel does regression for us, but for logistic regression, Excel doesn't have, we don't have under our data analysis anything that says logistic regression. So we're going to use optimization, which is part of Excel, to help us determine what these coefficients should be. Thank you.